Hi, welcome to our new unit, which will be dealing with factoring and quadratic equations. For today's lesson, it will deal with GCF, factors, and factoring with the distributive property. So the objective today is how do we find the prime factorization and GCF of integers and monomials. During the second half of this lesson, I will give you the second objective that will deal for the second part of this lesson. All right, so when it comes to factorization, there's two terminologies that you need to be familiar with. They're prime numbers and composite number. A prime number is a whole number greater than 1 with two factors, which are 1 and itself. So examples of prime numbers are 2, 5, 13, 17, 23. When you break it down to its factors, the only one you're going to get is 1 and itself. Composite numbers is a whole number greater than 1 with more than two factors. So for example, 4, 8, 21, 16, 24, 100, 200. Most of the times you have even numbers except two that are composites. For example, 4 can be broken down to 2 and 2, 8 can be broken down to 2 and 4, 21 can be broken down to 3 and 7, and so on. So for the examples dealing with that, they say factor each number and then classify it as prime or composite. So we have 36. It can be broken down into its into its factors. It could be 1, 36, 2 or 18, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So basically when you multiply those two factors, it will give you the product of 36. And is it a prime or a composite? Well, as we can see that we have more numbers, it's not just one in itself, it's a composite. 23. When you break down 23, you get 1, 23, and that's it, because 2 can't go into it, 3, 4, 5 can't go into it. 23 can go into it, but it's only just 1 and 23. So then that makes 23 a prime number. Prime factorization. Basically, it's saying that it's a whole number expressed as a product of factors that are all prime numbers. So this is where you're doing that tree, the prime factorization tree. So let's look at example example 3, dealing with 90. So we're going to break it down to its prime numbers. So we got 90. We break it down to 9 and 10. 9 and 10 can be further broken down. 9 can be broken down to 3 and 3, and 10 can be broken down to 2 and 5. Notice that 3 is a prime number, 2 is a prime number, 5 is a prime number. So basically we're taking a huge number and then breaking it down to its prime numbers, prime number products to give you that number. So at the end, you would just write it as 2, since there's only 1, 2. There's 2 3s, so 3 squared times 5. So basically, if you were to put this in the calculator, 2 times 3 squared times 5, you would get 90. So this is what they're talking about when it comes to prime factorization. You're breaking the number down to its prime numbers. And when multiply, you'll get the product that you started off with. All right, so now there are going to be times when you have a negative number. You can still do the prime factorization, but one of them has to be -1 because we're trying to remove that negative and then break down the positive number to its prime factorization. Prime numbers. So it says given a number, if a given number is negative, the first factor of the prime factorization will be -1. So as we can see, broke it down to -1 and then 144. Now we can go down to breaking down 144, which is 12 and 12. 12 and 12 can be broken down to 3 and 4. 4 can be broken down into 2 and 2. So for this one, which I made a mistake, so I'm going to fix that up. So this is also a prime number, and then okay, there we go. So as you can see, you got 3, 3, that's prime. You got 4 2's, which is a prime, and then we got the negative 1. So then there would be a negative 144 broken down to its prime factorization is 2 to the 4th times 3 to the 2nd times negative 1. And if you were to put this in the calculator, it will give you negative 144. So again, you're just breaking down the numbers into its factors, and then end up with the prime numbers towards the end. Right, greatest common factor. You have already encountered this in middle school, so you know if you've heard of GCF, then you should know what is going on. So with this one, GCF is greatest common factor, and that is a factor of both the original numbers. So they want you to find the GCF of 48 and 60. So I'm going to do it one number at a time. So for 48, I got 1 and 48 to give me 48, or 2 times 24 to give me 48, 3 times 16, and 4 times 12, 6 times 8. So I got that. Now I'm going to do 60. 60, 1 times 60 gives me 60, 2 times 30, 3 times 20, 4 times 15, and 5 times 12, and 6 times 10 to give me the factors for 60. So now that I've done both of them, we're looking for the common number that they both share, but it's the greatest one. If you start with 1, yeah, they have 1 in common, but it's not the highest one. 2, yes. 3, 4, 6, but notice how 12 is the highest number that they have in common. So the GCF for both of the numbers, 12. So basically, when they say greatest common factor, you're finding the common factor between two numbers or many numbers, and find the one that they have in common, but it has to be the highest number. Right, another example, 15 and 16. Let's do 15. 1 and 15, 3 and 5. So that's the factors for 3 and, 15, for 15. For 16, 1 and 16, 2 and 8, and 4 and 4. All right, did they say, what do you notice? Based on what I circled, we're looking for the greatest common factor. The greatest one that I can find was 1. They both have 1. So the GCF for both of them is 1. And they only have 1 in common. So when you see something like that, when you're dealing with numbers, 2 or more numbers, and their greatest common factor is 1, we call that relatively prime. That means numbers that have a GCF of 1. So that's just a terminology when you come across a problem like that where 2 or more numbers have just 1 as a GCF, and that is all. So it's relatively prime. Okay, so now they say the GCF of variables will always be the smallest power of the variable that both terms have in common. So you're not only going to deal with numbers, you're also going to deal with variables, and they're going to have the exponents. So when you have to find the GCF that includes the numbers and the variable, with the variables, you're looking for the smallest power. So the one with the smallest power between the two numbers, or how many between the two terms, or how many terms you're dealing with, you look for the smallest power with the variables. Right, so for 36x squared y, we're going to do that first. So again, I first find the factors of 36, 1 and 36, 2 and 18, 3, 12, 9 and 6, 6 and 6. And then what I did was I broke down the the x squared into x and x, and then put the y. So I got that one. Now I'm going to do the same for 54. 54, find the factors of 54. 1 and 54, 2 and 27, 3 and 18, 6 and 9. And then I put, since there's 1x, I put the 1x, I put the 2 y's because it's y squared, and then the z. Okay, now I'm looking for the greatest common factor, so I look for the number first. They both have 18. That is the highest common factor. And then I see each number. How many x's do they have in common? This one has 1. This one has 1. Even though that 36 has 2 of them, they only share 1 in common. Same thing with the y. 56xy squared z has 2, but 36 has 1. So they share 1 in common. So then now you multiply all those factors, 18, y, and x and y, and that's your greatest common factor. So again, when it comes to dealing with variables, look for the one that has the lowest power. That's the one that they're going to have in common. Because think about it, if your friend has 2 x's, you have 1 x, what do you have in common? You have at least 1 x in common, even though your friend has 2. All right, next one. Okay, this is the second half of the lesson where we're dealing with, oh my God, not polynomials, with factoring with distributive property. Distributive property. Oh my God, how come I messed that up? So the objective is, how do we factor polynomials by using the distributive property? So when factoring polynomials, the first method, this is going to be the first method because there's going to be other methods that you're going to learn in other lessons. So the first method is finding the GCF. So we have 6x squared plus 3x, and notice that it went to 3x times 2x plus 1. How did we get from this point to this point? So it says if we reverse the distributive property, we are factoring by expressing a polynomial as the product of a monomial factor and a polynomial factor. So notice that 3x times x squared, 2x plus 1, if you were to do the distributive property, you would end up with 6x squared plus 3x. But we're trying to figure out how do we work backwards from that. So in order to do that, we have to find the GCF. So basically, when you looked at this one, they found the GCF to be 3x. So then you divide 3x to both of the terms, and then you get your remaining factor inside the parentheses. So then you write it as a product of a GCF and the remaining factor. I'm going to show you an example in case the directions were a little bit fuzzy. So we have 9x squared plus 36x, and I'm just going to expand that. All right, so the first thing I did was I took each term and found, I'm going to find the GCF between those two terms. So for 9x squared, it's 9, 1, 3, 3, and then there's 2 x's because x squared. All right, now I do 36x. So 1, 36, 2, 18, 3 times 12 will give me 36, 4, 9, and 6 and 6, and then since 36, there's 1x. All right, what's the greatest common factor between those two? 9 is the highest common factor, and then they share at least 1x. So then the GCF for both of them is 9x. So I'm going to take that 9x and I'm going to divide each term into it. Remember, you did something about dividing monomials? Same rule apply. So 9 divided by 9 gives you 1, and x, the same base, you subtract the exponent, so you're going to end up with just x, 1x. And then for 36 divided by 9, it's 4. And since we have the same base, x to the first power, x to the first power, so you subtract, it'll give you 0. X to the 0 power is 1. So now, this is what you were left off with. That's one of the factors, but the GCF that you use to divide it to get to this, you have to bring it down and then bring down the leftover in the parentheses. So it's 9x times x plus 4. If you were to distribute this, 9x times x gives you 9x squared, and 9x times 4 gives you 36x. And there you go. So one thing to be careful with, if they ask you to find the factors for this, make sure that you end up with this answer. Don't try to redistribute again to get back to what you started off with, because then that would just be pointless. So basically you're working backwards to get to your two factors that gave you this polynomial, or in this case this is a binomial. Next one. Another example. First thing you do, find the GCF between those two. So for 16xz, we have 116, 2 and 8, 4 and 4, and then they have an x and a z. 1x, 1z. For 40xz squared, can move that out of the way. We have 140, 220, 410, 5 and 8, and we have 1x and we have the two z's. What do they have in common? What's their greatest common factor? The greatest common factor is 8xz. They have 8, that's the highest one, and they have at least one x in common and one z in common. So you take that, and then you're going to divide each term with the greatest common factor. And then again, do it term by term. So 16 divided by 8 gives you 2, and then xz, they'll cancel out, so you'll just be left with 2 for the first one. And then for 40 divided by 8, negative 40 divided by 8 is negative 5. The x's will cancel out, and z, same base, 2 minus 1 gives you 1, and then here you go. Bring down the GCF, and then this is the other factor that came from you dividing each term by the GCF. And there you have your answer. Make sure I have nothing's hiding. Yeah. Okay, next one. Oh, I lied. That was the last one. So let's go back. To recap, there was two objectives that you dealt with. We were dealing with GCF, factors, and factoring with distributive property. So you learned about prime numbers and composite. Primes is basically, when you break it down, it's just the one and itself. And composite is you can break it down, the number, into factors. And they could be many factors to give you that number. So 4, 8, 21, 16, 24. Usually it's even numbers, but not including 2. 2 is a prime. Every other even number on the number line is a composite number. And then you can have some odd numbers like 21. Trying to think of another one like 49. Those will be composite. Okay. You also learned about prime factorization. Basically, you're taking a number and you making that tree to find all the factors, breaking it down to find all the factors, and come and end up to the prime numbers that will give you that number. So basically, you're breaking it down to the bottom and get to the prime numbers. And if there's more than one of the prime numbers, then you either square it, cube it, whatever it is. So like this example, those 2 3s, you could do 3 square. And you also learned, negative number. When you do a negative number and trying to do the prime factorization, make sure you remove that negative 1. So it'd be negative 1 times whatever that number. Then break down that positive number to its prime numbers. You also learned about GCF, which is greatest common factor. You find all the factors for each number or each term, and then find the number that they have in common, but it has to be the greatest one. And we also learned about relatively prime. That means numbers that have a GCF of 1. So you could have like 5. If you had 5 numbers, you're trying to find oh my God, I'm trying to think of this, the factors. Trying to find the factors of them. If they all have 1 in common, then they're all relatively prime. And when you're dealing with variables in the term, you look for the ones with the lowest power. So that's what they will both have in common. If you have one that has x cubed and another one that's x squared, what do they both have in common? X squared, because one has 3, one has 2, but they do share 2 in common. And then you learned about trying to factor polynomials using the distributive property. So basically, you find the GCF of both terms or whatever terms, and then you divide by the GCF, use that GCF, divide each term by it, and then bring down the GCF, and then whatever was remaining based on your division will be the other factor, and then that'll be your answer. All right, so we have come to the end of this lesson. If you have any questions, again, feel free to ask and email me, and that is all. See you around.